Okay.
Great.
The title of the presentation is the hazards in Malawi and the current activities that we are doing as the University of Malawi. In terms of the presentation outline, first of all, I'm just going to go through an overview of the country and its hazard profile, just to give you an idea of what is the current situation. And then I'm going to talk about some of the things that we've been doing either through prepare and our own activities, and then draw the conclusions. So we are in the Eastern African Rift System, the southern part, the area shown by the red rectangle at the bottom here. So it's an area that is seismically active, but it's also topographically very diverse. We have areas that are very flat, but areas that are also very high. The highest is nearly 3,000 meters above the sea level. So these variations in altitude have also implications in terms of other hazards that the country does experience from time to time. Hazards triggered by rainfall distribution, for example, or slope stability. So in terms of the hazards, in Malawi, I categorize them into two main types. Hazards that tend to have a slow settling time. Oftentimes when we deal with hazards, most of us are concerned with those that take place very rapidly. So things like earthquakes that can rupture within seconds or a minute. But there are other hazards that are very slow, and we tend to not give them so much attention. So in Malawi, for example, we have an issue of soil erosion and land degradation, which has big implications for agriculture, for example. You can see in this slide, for example, in the last 2 years, World Bank was giving the country about 157 million just to try and restore degraded water bodies and land resources. This is a huge amount of our GDP. The current estimates actually estimate that nearly 7% of our GDP is lost through land degradation. So this is a potential hazard which is perhaps given little attention. So one example of the slow settling hazards. The other example that I'm particularly concerned with are, for example, expansive clays. So within the Rift Basin, we have areas which have large deposits of clays, and some of the clays that we have in those areas are these expansive clays, the clays that swell when they absorb a lot of moisture and then shrink when they lose the moisture. And what happens over the course of time is that buildings are dancing or are responding to this kind of movement, swelling and shrinking, swelling and shrinking. And then eventually the buildings develop a lot of cracks. We have places in this country where these things have taken place, and whole structures which were constructed using lots of money are lost and abandoned in the process. So this is again another example of a hazard with a slow settling time. But on the other extreme, we have those hazards which are rapid, hazards like the earthquakes. We all are aware that this country is within the East African Rift System, like I said at the beginning. And so most of the areas within the country are seismically active. Here is just a photo of an earthquake damaged building during an earthquake that took place in Karonga in 2009. So earthquakes are one prominent hazard that we have in this country. But we have other hazards too that I describe as geomorphoclimatological, so a mixture of geomorphology and climatic events. So here is the city of Zomba, for example, and you have within that slide areas that were devastated by a landslide that was devastated part of the city in 1946. But these landslides have taken place time and time again. And we have another one southeast of Zomba, a town called Palombe, was also devastated by a landslide event. You can see all the debris that devastated this town on this photo that you see in 1991. This event had nearly 500 people killed because of these landslides. Most of the landslides that we have here are geomorphological, so they are occurring in high places, but sometimes they seem to be triggered by tropical cyclones that come from the Indian Ocean. So I think these are very important hazards that need to be given attention. We have rare cases of landslides that have been triggered by earthquake events. For example, there's a hill in the central Malawi, which is called Manyani, which was experienced an earthquake, a landslide soon after an earthquake that took place in 1989. Again, we don't have a good understanding of which landslides are taking place as a result of the technical tectonic processes and those that are climatological in nature. And then we also have issues to do with the floods. Although the Malawi is landlocked, but it's not far away from the Indian Ocean coast. So this is a map of the Indian Ocean coast, you can see. And these are various tropical cyclones that do affect Malawi from time to time. From the database, these are just a few, but there are lots of others. And on the right, you can see, for example, a washed out vehicle, which was devastated due to the effect of the tropical cyclone that recently hit us, Anna. And then following this, we've also had another tropical cyclone called Gombe, just this year alone. So Malawi is from time to time affected by these tropical Indian cyclones that do that go inland, and then they have huge implications on either flooding, but also the geomorphological landslides that I talked about earlier on. Now, in terms of our activities, that's the next part of the presentation. As University of Malawi, we do lots of activities. I'm not going to repeat what others have already said in terms of the Prepare project, because we were also part of that project, but other people have ably spoken about this, so I'm going to skip this, just to highlight that we worked in that project as well, and we are also keen to work with colleagues, depending on whatever we can agree later on at the end of this webinar or whenever possible. But as a department, we have also been working on mapping some of the rift sediments, trying to date them. One of the challenges that we've seen in the rift areas is that, for example, when we have an earthquake, there are lots of solifluction activities, so mixing up of various sediment, water, and so it becomes very difficult to precisely understand whether a fault is active or it's not active. And so we are trying to date some of these sediments to be able to relate them to their tectonic activities. And we also want later on to do some paleoseismological work to try and map if there are some odd earthquakes that are not perhaps recorded in the current earthquake catalog that we have as a country. We are aware that some areas of the rift do not have these sediments, so we are also trying to use other geomorphological techniques, for example, using nick points to try and estimate some tectonic effects and at what rate some of these processes are taking place, to be able to indirectly determine how old some of these faults are within the rift. So that's one of the activities that we're doing. The other activity is related to landslides. So we have engaged some of our students to be able to visit some of these areas in the high geomorphological areas, because we realize that it's not only those two areas I showed earlier on which have experienced landslides, but there are other areas where we have had perhaps dormant landslides. And so we want, sometimes from time to time, depending on our resource availability, we give student projects to be able to visit some of these areas and work out and find out whether they can map odd landslides in those areas. We have people in our hydrology section who are also interested to estimate river flow estimates, because most of the river systems in this country do not have monitoring gauges, and so we need to be able to predict whether rivers, at what point rivers swell and flood. And so some friends or colleagues in the hydrology section are working on this. The other activity we are proposing, and we have been working on this, it's not yet fully done, is that we also want to streamline issues to do with hazards, various types of hazards in our curriculum, because we know that students graduate from the university perhaps without a good understanding and appreciation of some of these issues. So we, as a department, we decided that we revisit our curriculum and try to build in aspects of hazards and disasters in various aspects. We have a section in the department that deals with town planning, for example. And these days, you cannot talk about town planning without having an understanding of hazards or what potential hazards exist in an area, in proposed town areas. So we think by doing this, we incapacitate our students so that when they go out there, then they know exactly what they are trying to do. We also propose that perhaps we should try to map the young sediments within the rift areas to understand the distribution of the clays. I talked about the swelling clays. At the moment, the big challenge is that we don't understand the spatial distribution of these clays. So we want to understand where these clays are, and so that we can use this information for planning to be able to say, when you design buildings in these areas, perhaps these are precautions you need to take. Yeah, so in conclusion, therefore, we can see from what I said that we have a diverse range of hazards that are present in this country, both slow and fast ones. But from what I said, we see that there's little attention that perhaps is being given to slow settling hazards. And we also need to have curricula that are designed to respond to various hazard issues in the country. Thank you for your attention.